Let's take a look at how you can leverage Helm charts and Kubernetes manifests to deploy an environment in Bunnyshell. So I have here the demo books application composed out of 3 components: a Postgres database, an API, which is the backend, and a frontend, which consumes the API. Let's take a look at the configuration in order to see how these components were defined. So I have the environment variables defined. The Postgres password is actually a secret. And let's dive into the components. We have 2 Docker image components for the front end and for the backend. We can see that they have Git information, the repository and the branch, as well as the path within the repository. This is front end and backend respectively for the backend application. And we can also see that we have the properties needed for a build in Docker. We have the context, the Docker file, the target, which is obviously optional, as well as the build arguments. Moving past these Docker image components, we can see the first Helm chart component. This is for the database for Postgres. And one important thing to know here is that essentially in Bunnyshell, a Helm component implies running a sequence of user-defined scripts. So basically we have this deploy attribute under which we have some scripts to run. These are user-defined. When adding a component in Bunnyshell, when adding a Helm chart, we help you with an initial template, but you still need to make the necessary changes for your application. So the first step is to actually create the values file. Then the repository is added, the Helm repository, and afterwards the Helm chart is installed. An important thing to note here is that this Postgres host variable is being defined here. It's being built actually, as it will be exported here under the export variables property to be used in other components. In this case, the API will use it to know to which database it should connect to. Similarly to the deploy attribute, we have the destroy attribute as well as the start and stop attributes, which also run some scripts. In this case, we can see that the start sets the number of replicas to 1, the stop sets the number of replicas to 0, while the destroy performs a Helm uninstall. Pretty straightforward for a Helm component. Let's move on to the Helm API in order to see what this brings to the Helm component definition. As you may have noticed, the Helm chart for the database was installed directly from a repository, so we didn't need a Git repository of our own. But in this case, we have the Git repository for the application. We have the Git repository, the branch, and the application path for where the Helm chart is located, right? So we also have a runner image. This is the image that will instantiate the container in which all of these commands will be ran, right? So basically in this image, Bunnyshell will clone this repository with this branch and this application path, and then it will run the scripts under the deploy when deploying, and this also happens for the destroy, start, and stop flows. Similarly to the previous Helm chart, we build here the values file, and after that we just install the Helm chart using Helm upgrade -- install, passing the values file and the Helm chart. So this was the backend component, which is a Helm chart. I'm going to collapse this. And the last component I want us to take a look at is the front-end component, which is based on a Kubernetes manifest. It is very similarly to Helm, the way it's defined. The only exception is that, not leveraging Helm's templating system, you will probably need to perform some replacements of your own. In this example, we performed them using sed, and as you can see here, you can interpolate variables for the image being used or for the domain which will be generated for this environment, or the namespace used in Kubernetes or the environment unique, and so on. A full list of these variables which can be interpolated can be found in the documentation.